Okay, so now who can tell me what all you know about numbers? What kind of numbers are you aware of till now?
Ma'am, we are aware of natural numbers, rational numbers, and ma'am, positive numbers and negative numbers.
Whole number.
Very good. Okay, right. So you
Decimal
said
numbers.
right.
Ma'am,
Very
acute
well.
number, whole number.
Okay. What's acute number, Mridula?
Yes, ma'am.
Yeah. What is acute number? I think you just said acute number. Did I hear it incorrect?
Ma'am, sorry, I'm acute
Ma'am, she said
network.
acute number.
All right. So as you all said, we have
Ma'am,
natural
again your
numbers.
voice went low.
Okay. We have natural numbers. All right. I just check my internet connection. Just give me 2 minutes. Am I audible clearly now?
Yes,
Yes,
ma'am.
ma'am.
Okay,
Yes,
is it
ma'am.
much better? All right, thank you. Okay, so natural numbers. What are natural numbers?
1, 2, 3, 4, 5.
All right, right. So natural numbers are basically counting numbers, right? The numbers which you use to count. All right, and so on. Next, what are whole numbers?
Ma'am, whole numbers are natural numbers which include zeros as well.
Exactly. So it's 0 plus all the natural numbers. Now you see, there is a way of denoting these collections, right? So if I say that the collection of natural numbers, this is the whole collection of natural numbers 1, 2, 3, 4, and it goes on until infinity. So this collection is denoted by the capital letter N, right? So it is denoted by N, and the collection of whole numbers is denoted by the capital letter W, right? So if I say what are whole numbers, as you said, whole numbers are 0 plus the collection of natural numbers. All right. Then someone said positive numbers and negative numbers. So what kind of positive numbers? Okay, how about, all right, so someone said fractions, someone said decimals. So what is the relation between fractions and decimals?
Ma'am,
Anyone?
ma'am, that is, we can convert fractions into decimals and decimals into fractions.
Right, exactly. Can you give an example? Can anyone give an example of this?
Yes, ma'am. Ma'am, like 5 upon 10 is an example of fraction and 0.5 is the example of decimal.
Exactly. So this is the same thing as 0.5. All right. So now this is one thing. And then let's come to negative numbers. In the sense, acha, can anyone tell me what are integers? I'm sure you must have heard of that before. Integers, the set of integers is denoted by Z. All right. And what are integers?
Ma'am, it's a group of positive as well as negative numbers.
Okay. So is minus 0.5 an integer?
No, ma'am.
Well,
Sorry, Veer, what did you say?
ma'am, it's a decimal.
Right, it's a decimal, but it's not an integer, right? So integers are basically, what are integers? Integers are basically, you have all the natural numbers, right? All the natural numbers, then you have 0, and all the negative of all the natural numbers, right? So you have all the natural numbers 1, 2, 3, 4, and so on, plus 0, plus all the negatives of the natural numbers. Does that make sense?
Yes, ma'am.
Okay. So that is the set of integers that is pretty clear to you. And you guys also know that decimals are different and integers are different. So that's cool. Now let's talk a little bit about rational numbers. Has any one of you ever heard that term before, rational numbers?
Yes, ma'am.
Yes,
Yes.
ma'am.
Okay. Can someone tell me?
Yes, ma'am. Ma'am, it's a number in the form of P upon Q, where P and Q are integers and Q is not equals to 0.
Okay. All right. So do you know why we call them rational numbers? Okay. Does anyone know the meaning of rational?
Ma'am, numbers in the form of P upon Q.
Yeah, that's correct. But what about why are they called rational?
Ma'am, because of ratio.
Exactly. Right. So because of the word over here, ratio. And what is ratio? We all know that ratio basically means, like, for example, if I say 2:5, this is the ratio. Then this can also be written as 2/5, right? So this is the ratio. So let's say you have 1, the number 1. So 1 can also be written as 1/1. This is an integer and this is an integer. So this is written as uh, one integer p upon another integer q. Basically, it is written as a ratio of two integers, right? Are there any other ways you can write 1?
Ma'am, yes.
Yeah, you can
Like,
say,
ma'am, the example are 2 upon 2, 10 upon.
right, exactly, 10 upon 10 and so on. You can write it in infinitely many ways, right? So what can we say about 1? Is 1 a rational number?
Yes, ma'am.
Yes, ma'am.
Yes. Okay. All right. So 1 is a rational number because it can be written in the form of P by Q. What does that mean? It means it can be written as a ratio of two integers. All right. So can anyone give me more examples of rational numbers?
Ma'am,
Ma'am,
like 3 upon 5, 10 upon 2,
Okay.
and so on.
Right. What about -5? Is this a rational number?
Yes, ma'am.
Okay. How can you write it in the form of as a ratio of two integers?
ma'am, -5/1.
Very good. -5/1. Anyone else? Would you like to put any other?
Ma'am, minus 10 by 2.
Right. Very good. -10/2. Or you can say 20 by -4. Right.
Yes,
So,
ma'am.
all right. So -5 is a rational number. Okay. Next, how about 1.5? Is this a rational number?
Ma'am,
Yes,
it's
ma'am.
not rational number.
Yes, ma'am.
Okay, just give me a sec. Yeah, I'm so sorry. Yeah. So how can we write I'm sorry, how can we write 1.5?
Ma'am, 15 upon 10.
Right, 15 upon 10. Anyone else? Okay. Can we think about 1.5 as it's the number between 1 and 2, right? It's the half of 1 and 2. It lies halfway between 1 and 2. Or you can say it is basically, what is 1.5? It is 1.5, isn't it?
Yes, ma'am.
Yes, ma'am.
Yeah. So 1.5 is a mixed fraction. How can you convert this into an improper fraction? What will it become? 1.5.
Yes,
Ma'am,
ma'am.
3 upon 2.
Right, 3 upon 2, right? So does, if anyone has any doubt, you can always be free to ask. All right, don't hesitate. So everyone's clear, right? How we got 3 upon 2?
Yes, ma'am.
Okay,
Yes, ma'am.
all right. So that's 1.5. Next, let's talk about, how about 0.3 and so on. Is this a rational number? By the way, this can also be written as 0.3 bar. You know what bar means?
Yes, ma'am. And 3 repeats.
Yeah, 3 repeats itself. So okay, so if I write 1 point, let's say 2, 3, 4 bar, what does this mean?
Ma'am,
Ma'am, it
that 3
means
and 4 are repeating.
Right, very good. 1.2, 3, 4, 3, 4, and so on. Okay. So is this a rational number? And if yes, then how can you write it in the form of P by Q?
ma'am, yes, it's a rational number. And ma'am, we can write 0.333 as in a rational number by one method.
Okay. So, Mridula, you're aware of that method. That's cool. Anyone else knows how to write this in the form of a ratio of two integers? Achha. Have you ever come across, when you're trying to do division and you get stuck up with something like 1 divided by 3, or it could be 10 divided by 3? Something, you have something in the numerator which is not a multiple of 3, and the denominator is something like 3, right? So the um, the quotient comes out to be 0.3 bar, right? 0.333 keeps on repeating. So 0.3 bar can be written as 1 by 3. Okay. Similarly, you must have seen 0.6 bar. All right. Okay. So these are all uh, examples of rational numbers, right? We saw this was a rational number, 1 was a rational number, -5 was a rational number, and so on. All of these that we've seen till now are rational numbers. So can you tell me what are irrational numbers then? So irrational numbers,
A number that cannot be represented.
right? So irrational numbers are basically, by the name itself, we can judge that irrational numbers are the numbers which are not rational, right? So, does anyone know of any famous examples of irrational numbers?
Ma'am, root 2.
Two, do you know what's the value of root 2?
No, ma'am.
So, root 2 is 1.4142135 and so on, right? So, it keeps on continuing. Any other examples of irrational numbers that we come across?
Ma'am, root 3.
All right, root 2, root 3, and so on. Root 3, root 10. What about pi?
Yes, ma'am. Pi is one of them.
Pi is an irrational number. That means it cannot be written as a ratio of two integers. So, does anyone remember the value of pi?
Ma'am, 3.14.
Right. So it's 3.1415925 and so on. It keeps on continuing. It doesn't just stop at 3.14. And so now tell me, if I write 3.14 over here, just this number itself, is this a rational number or not?
Ma'am, yes, it's a rational number.
Right? Okay. Why is it a rational number?
Yes, ma'am. Ma'am, rational number is 22 upon 7. Ma'am, your mic is off.
Yeah, sorry. So 3.14 is a rational number. What do you think, Veer, Zoya? What do you guys think? Hamna?
Yes, ma'am, it's a rational number.
Okay, so it is rational. So by the way, do you know over here we represented the set of all these things. We said this is n, this is w, this is z. Do you know what is the set of rational numbers represented as? Okay, no problem. It is represented as q. Why q? Because q basically means quotient. It stands for quotient. Anyway, so let's come back to our discussion. So, all right, 3.14 is a rational number. Cool. You said 22 by 7 is also a rational number. Does everyone agree to this? Is 22 by 7 a rational number or not?
Yes, ma'am.
Yes, it is. It is also a rational number. Acha, so if 3.14 is a rational number, but pi, we are saying that pi is an irrational number. How is that possible?
Ma'am, because we only take the approx value.
Yeah, right. So when we are doing our sums and we are doing our calculations and we write, we replace pi as 3.14, that is just approximate value and not the exact value. So basically, if I say this, is this right or wrong?
Ma'am,
Ma'am, it's
right.
right.
Okay, you're saying it's right. But then this is irrational. And on the right hand side, we have a rational number.
Ma'am, it's not. Ma'am, it's not. Ma'am, it's approximate.
Right, right. So the sign over here should be approximately equal to. Okay, it's not exactly equal. So the same logic we can apply if someone asks us that, well, we've always been replacing pi by 22 by 7, right? So pi should be equal to 22 by 7? No, it's not equal. They're approximately equal. So does anyone know what is the value of 22 by 7? Have you ever tried dividing 22 divided by 7? Has anyone ever tried? All right, how about you try it right now and tell me what the value comes out to be? Has anyone done this yet? Okay, Zoya?
3.14.
Okay, Hamna is saying 3.14. Have you?
Ma'am, 3.142897.
Very good. Yeah. So you will realize that once you do this, when you divide this, in the quotient you will have 3.142857, and so on. This part 142857 will keep repeating. So now tell me, is 22 by 7 rational or irrational?
Ma'am, irrational.
Okay, you're saying, Zoya is saying it is irrational. Anyone else?
Ma'am, it's both rational and rational.
Oh, so something can be both rational and irrational. What makes you think so? See, the definition of irrational, what is the definition of irrational? Something that is not rational. So how can something be rational and not rational at the same time? Think about it.
Ma'am, maybe we can see the perspective like if we in the fractional form, then it is 22.7, but if we see in the decimal form, then it can be irrational too.
Okay. So let's clear a few things out. You guys are on the right track. Let's clear a few things out. If you can write something in the form of P by Q, where P and Q are two integers and Q is not equal to 0, right? This is the formal definition, right? So if you can write something like this, then it is rational. So basically, what we mean to say is that all fractions that we have, that we are accustomed to, all the fractions that we know of, that we've studied till now, till grade 9, all the fractions are rational. What about decimal numbers? Now see, there are different types of decimals. Okay. Now you're gonna have to listen to this very carefully. So one type of decimal is known as terminating. There's one thing called terminating and there's something called non-terminating. Will anyone explain to me what these two things mean?
Ma'am, terminating is a number that, ma'am, it's a decimal number that never ends and it never repeats. And non-terminating is a number that ends and at a point.
You said the right thing, but actually the opposite, right? So what you said for terminating, it has to be the definition for non-terminating. So terminating means, like, if I say 1.5, this is terminating. What does terminate? Okay, what does terminate mean? Or you must have heard, when you go to the airport or something, terminal. So terminal basically means terminal or terminate. It means something, a place where something comes to an end or something stops, right? So that's the meaning of terminating. So terminating means the decimal is stopping over here, 1.5. Similarly, you have, let's say, 2.0001. This stopped at some or the other point, right? So this is terminating. Now, Hamna, can you please give me an example of non-terminating? We have covered a few examples just very recently. Hamna, am I audible?
Yes, ma'am.
Yeah. So can you give me a few examples for this one? Non-terminating, this one?
Ma'am, 3.142857.
3.1457
That keeps continuing on.
bar. So we put the bar over here. Very good. All right. Mridula, would you like to give another example?
Ma'am, 0.1501 and 500. Ma'am,
Okay. Can you repeat that, Mridula? 0 point. I think you said something like this, right? Is this what you meant? Okay, I'm not able to hear you. All right. So this is another example. Why is it non-terminating? Because this the decimal expansion is not stopping at any point. You see over here it's like 0, 1 and then 0, 0, 1. So at every step after this you're going to have 4 zeros and then 1. So it keeps on going like that. It's not stopping at any point. Another example of this could be, you can say 3.14 like pi, right? The decimal expansion of pi. 3.14159265358979. So on. So this, what's going on over here is that no numbers, no set of numbers or digits is repeating. Over here you saw that 142857 was repeating, but over here nothing is repeating. It's just going on like random numbers. Another example is, let's say, 0.234 bar, right? So over here what's happening is you have 0.23434. So 34 and 3, like 34 is continuing, it is repeating. So right now we're talking about terminating and non-terminating. Terminating means it stops at one point. Non-terminating means it is endless. It goes on until infinity. Now we will talk about another point, which is whether it is repeating or non-repeating, right? So when you're talking about non-terminating, the ones that go on till forever, the non-terminating ones could be repeating or it could be non-repeating, right? So Veer, can you just give me a very quick example of a repeating decimal expansion and non-repeating decimal expansion? Veer? Soya, would you like to give an example for repeating?
Yes, ma'am. Ma'am, like 3.14141414 till the infinity, and non-repeating 141141114, ma'am, like this.
Very good, very good. Okay, any doubts up until now, you can frankly ask. Don't hesitate.
No, ma'am, no doubts.
No, ma'am, no doubt.
3.161 bar, and this is it's non-repeating, as in no pattern, the number isn't repeating itself. All right. So I hope it is clear until here what is repeating and non-repeating. So let's go 2 slides back. Okay, here we have what were we talking about? We were saying whether, like, we want to see whether a number is rational or not. So we said if it's a fraction, it is definitely rational. But we know that fractions can be converted into decimals, right? So if it's a decimal, then how do we know whether it's rational or not? If it's a decimal and it is terminating, then it is rational. This is the first case. Otherwise, if it is non-terminating, as in it goes on forever, if it is non-terminating, then it has to be repeating, like 3.14 bar or 0.3 bar, right? 0.3 bar, as we said, it is 1 by 3. So non-terminating, if it is non-terminating, then it should be repeating. Then this will be rational. Is this clear until now?
Yes, ma'am.
Yes, ma'am.
All right. So now let's take a look at a few examples. Okay, so first let's classify our all the numbers that we have into rational and irrational. Okay, so we have, let's say, this circle stands for all rational numbers. Okay, and anything outside of this circle, let me just, so anything outside of this circle will be, what will it be? Veer? Anything outside of this circle of rational numbers will be
Ma'am, irrational, I think.
right. That's correct. So anything outside the circle will be irrational. All right. So in rational numbers also, we know that there are different types of numbers. Just like you guys said in the very beginning, there are different types of numbers, different classifications of numbers. Like we have integers, right? Then so there are going to be some numbers which are rational numbers, but they are not integers. Can you give me an example of a rational number which is not an integer, Mridula? You're not audible. Okay, so yeah,
Yes, ma'am. Ma'am, 0.6 bar.
very good. 0.6 bar is rational, but it's not an integer. I'll write that later. Okay, so within integers, we have something called the natural numbers. Natural numbers, right? Okay, so now we're going to take a look at some numbers, and you guys will have to classify which collection or which set all of these numbers lie in. Okay, so let's first look at, right, so we have 3. 3 minus 5, 0.25, 7, 0.2713 bar, 10, 7, 2 by 9 by 7, and we have minus. Okay, so let's start. Please, can you hear me? Am I audible? Alright. Hamna, can you tell me the first one?
Ma'am, it's a natural number.
It's a natural number. So I should place it in the green circle. Right? So 3 comes here. It's a natural number. Okay. What about minus 5?
It's a negative integer.
Right, it's a negative integer. So basically it comes under integers, right? Can I write it under integers?
Yes, ma'am.
Yes.
Okay. So now Mridula, can you tell me what about 0.25?
Ma'am, it's a irrational number.
It's a rational number. Why? Because we can write it as 1 by 4. We can also write it as 25 by 100, right? So it is a rational number. Alright. What about 22 by 7? Zoya?
Ma'am, irrational.
Zoya says 22 by 7 is irrational. Why do you think so, Zoya?
Ma'am, because at certain point, the numbers gets repeating till infinity.
Okay. But then we just saw that the very definition of rational numbers. Okay, so if you just look at a number, the the definition by which you can decide this number is rational or not is look at it and ask yourself, is this written as a fraction where numerator and denominator are two integers? So just look at 22 by 7 and tell me, is this written as a ratio of two integers, yes or no?
Yes, ma'am.
So by that definition, it has to be a rational number, right?
Yes, ma'am.
Right. So it has to be a rational number. But now the confusion that is coming up is, well, when we look at the decimal expansion of 22 by 7, it comes out to be 3.142857 bar. That's your concern, right, Zoya?
Yes, ma'am.
Okay. So let's just take a look again at the definition of rational numbers when you look at their decimal expansion. Rational numbers when you look at their decimal expansion. Okay. We said if it is terminating, as in if it is something like 0.25. So Zoya, tell me, what do you think this is? Rational or irrational?
Ma'am, rational.
Okay, it is rational because you're saying it's terminating. All right. What about 0 point or okay, just a sec. What about 1.333 and so on? It is going on till infinity. What about this, Zoya?
Ma'am, irrational.
It is irrational, okay. But you can just convert this into a fraction. This is okay, okay, now who will tell me if you convert this into a fraction, you convert 1.3 into a 1.3 bar into a fraction, what will the fraction come out to be? Anyone? All right, let's not go into the details of that because you'll have to sit and do the method, right? So instead of that, yeah, let's just do 0.3. Now, Zoya, can you tell me 0.3333? If something is coming out like this, then it is
Ma'am, ma'am, I think it's irrational.
no problem. It's okay. So you still think it's irrational. All right. But if you convert this into a fraction, it turns out to be 1 by 3. Agreed, Zoya? Yes or no?
Yes, ma'am.
Right. So, what is our definition of a rational number say?
Ma'am, it is that if a number is represented in a form of P upon Q, where P and Q are integers and Q is not equal to 0.
Right. So, can 0.3 bar, I'll ask this again, can 0.3 bar be written as a number of the form P by Q? Can it be written like this? Yes or no?
Yes, ma'am.
Yes, it can. So, by that definition, it will be
Ma'am, rational number.
rational number. Is it clear now?
Yes, ma'am.
Right. So, now can you tell me the same thing about 22 by 7?
Yes, ma'am. Then it will be rational number.
Right. It is a rational number. So, I should write it under rational numbers. 22 by 7. Right. So, if
And
anyone, yeah.
and ma'am, 3 can be written in integers too. So ma'am, we have to put in integers also, or we should only put it in natural numbers category.
See, this green circle is inside the blue circle, right? So that means all of the natural numbers are going to be a part of integers. Is that clear?
Okay, ma'am. Yes, ma'am.
All right. So now the next thing is 0.2713 bar. So, Ridula, can you tell me this one?
Ma'am, it's irrational number.
You say that it's an irrational number. Can you tell me why you think so?
Ma'am, because it's never ends in rational number.
So over here again we are coming back to this, that if you have a decimal in front of you, how do you decide whether it is rational or irrational, right? So just take a look at this, the check that we have here. If it is terminating, then it is clearly rational and everyone agrees to this, right? But if it is non-terminating, right, so there is a possibility that you have a decimal which goes on forever. It is non-terminating, but it will still be a rational number if if the numbers in it, if the digits in it are repeating. Like we took a look at this. Similarly, you can take a look at 0.2713 bar. So how is it repeating? Which part of it is repeating, Rudula?
Ma'am, 142857.
That all right. So that is done. But take a look at this 0.2713 bar. This one. Which part of this decimal is repeating?
Ma'am, 13.
1 3. So I can write this as we can write this as 0.27131313 and so on. So over here something is repeating, and what is that? That is 1 3. And we said that if you have a non-terminating decimal, as in it goes on forever, but there are a few digits that are repeating, then it is rational. So by that definition, do you think that this is rational or irrational?
Ma'am, it's rational.
It's rational. So I want all of you to now tell me, is the definition of a rational number clear?
Yes, ma'am. Yes, it's clear.
Yes, ma'am.
And so now I want you guys to tell me, if we have a decimal expansion, we have a decimal number. If you look at it, how will you decide whether it is rational or irrational?
Ma'am, if the number is terminating, then it's a rational number, and if it's non-terminating, it's a irrational number.
Not necessarily. Your first part was right. But if it is non-terminating, but it is repeating or it is recurring, right? Repeating or recurring is the same thing. Recurring. If the number is non-terminating, just like this one, okay, just like this one, if it is non-terminating but repeating or recurring, then it is rational. Okay, so we'll take a look at a few more examples, and I hope it will be clear then. So 0.2713 bar. Since it's a bar over here, it repeats itself, then it is a rational number. And always, if you get confused, it's okay to get confused. But if you do, just remind yourself of the example of 0.3 bar, right? 0.3 bar means it is 0.3333 and so on. So it is clearly non-terminating. It goes on forever. But we still say it is a rational number. Why? Because we know that this is nothing but the same as 1 divided by 3. Right? So we know that this is a rational number. Is that clear now?
And is all the non-terminating repeating numbers are rational number?
Yes. All non-terminating repeating decimals are rational numbers. Okay. Now let's take a look at root 10. Anyone?
Ma'am, it's a rational number.
One sec. Hamna, did you say something?
Ma'am, it's irrational number.
I couldn't hear you. Could you repeat?
It's irrational number.
Okay, you were saying it's irrational. Mridula?
Ma'am, it's irrational.
Irrational. What about you, Zoya?
Ma'am, irrational.
Irrational. Veer?
Yes, ma'am.
Yeah. What about root 10? Is it rational or irrational?
I think it's irrational.
All right. So all of you are agreeing that it is irrational. Okay. So root 10 is irrational. What about 14 by 7, Veer? Okay, Zoya?
Yes, ma'am. Ma'am, it can be done in integers and rational numbers too.
Okay. So what is 14 by 7? 14 by 7 is nothing but 14 by 7. What is this?
Ma'am, 2. 2
It is
upon
2.
7 or 2.
2 upon 1 or 2, right? This is 2. So yes, it is a rational number. Why is it a rational number, Mridula?
Ma'am, because it's ending at a point.
Okay, very good. That's one way to look at it. Another way to look at it would be, can anyone else add on to it?
Ma'am, that it can be represented in P upon Q form, where Q is not equal to 0.
Yeah, right. It can be represented as P by Q. And what is that P by Q? Basically that means you can write it in the form of a fraction. So there you go. There's a fraction. So that's why 2 is a rational number. But 2 is an integer also, right? We know that 2 is an integer and 2 is a natural number also. So we're going to write it over here. 2 is a natural number. Or basically what was our 2? It wasn't 2. It was 14 by 7. And 14 by 7 is equal to 2. So is it okay if I place it here? Any problems, anyone?
No, ma'am.
So why didn't I place it in the blue circle? Because, well, of course, it is an integer. It is a rational number. I could have placed it here as well. I could have placed it here as well. But I placed it here because it is a natural number as well. So I placed it under natural numbers. So now it automatically comes under integers also, and it automatically comes under rational numbers also. Now, next, let's look at 2 pi. So, Hamna, can you tell me 2 pi?
It's irrational.
It's irrational. What do you think, Zoya?
Ma'am, irrational.
It's irrational. Why is it irrational? Because it is a multiple of pi. We know that pi is irrational, so any multiple of pi will also be irrational, right? So we have 2 pi.
Yes, ma'am.
Now, Veer, can you tell me root 9 by 7? Just one. Veer, can you show me? Okay. Zoya?
Yes, ma'am. Ma'am, I think it's irrational.
Do you think it's irrational? Why do you think so?
Ma'am, because root 9, ma'am, because it doesn't fit in the category that it says that if a number is presented in P upon Q, so I don't think so that can become under that.
Okay, yeah, that makes sense. All right. What do you think, Hamna?
Ma'am, it's irrational number.
Okay. You're also saying here it's irrational. And what about you, Mridula? What do you think about root 9 by 7?
Ma'am, can you repeat it? Ma'am, there's a network problem in my PC. So,
Okay. What do you think about root 9 by 7? Is it rational or irrational?
ma'am, it's rational.
You think it's rational. Why do you think so, Mridula?
Ma'am, because the root 9 is equal to 3.
Exactly. Right? So is that clear now, Hamna and Zoya? Root 9 is nothing but 3, right? You have
Yes,
root
ma'am.
9. This is equal to 3. So this is 3 upon 7. So 3 by 7 is what? It's a rational number. Basically, it's a fraction. So it's a rational number because it can be written in the form of P upon Q. So there we go. It is root 9 by 7. Okay. Now, can anyone tell me about minus under root 25?
Ma'am, it's a rational or integer. Ma'am, it's an integer number.
Okay, it's an integer. Right. So first of all, it is rational. Now, if I ask you whether it is rational or irrational, you will say it is rational. Now, rational numbers also come in many types. There are integers, there are natural numbers, and so on. So, among the rational numbers, this is an integer. Why is it an integer? Because minus of root 25, this root 25 is nothing but 5, right? So instead of this I can just write 5. So this turns out to be minus 5, right? So minus 5 comes over here. So minus root 25 is an integer. These are both the same thing, minus 5 and minus root 25. So any doubts up until now? Anything that you found troublesome or problematic? Anyone?
No,
No,
ma'am.
Okay, so now let's quickly take a look at how to we said that we can convert numbers from decimals to fractions. So basically we said that if there is any rational number, then it can be written in the form of p by q. So if I say 0 point, or let's forget about 0 0.3, you all know that it's 1 divided by 3. So how about 1.3 bar? So 1.3 bar, this is, now who will tell me, is this rational or irrational?
Ma'am, rational.
ma'am, it's rational.
Very good. So this is a rational number. But we know that any rational number, if any rational number is given to us, we can always write it in the form of P upon Q, where P and Q are integers. So how do we write it in that form? So there is a way to do that. So do you guys want to find out what that way is? Okay, I'm not going to wait for the answer. So 1.3 bar, let's give this the name of x. All right, let's say that x is equal to 1.3 bar. Now what we do, we see how many digits are repeating. 3. Over here only 3 is repeating. So we say we will multiply this equation. Let's call this equation number 1. We will multiply this with 10. Why 10? Because the repeating digits are just 1. So we have 10x is equal to, now who will tell me what should I write on the right hand side?
Ma'am,
13.3 bar.
Right. So 13.3 bar. Does anyone have any doubt about this? Any?
no, ma'am.
Everything's
No,
clear?
ma'am.
Now what we'll do is we can proceed from here in 2 ways, but I'll just show you one. So one way, all right, I'll just show you both. So one way is you can say equation 2 minus equation 1. All right. But then you might ask, well, why are we doing this? Why are we doing equation 2 minus equation 1? And how do I know that I have to do that? So you see this equation, you can write it as 10x is equal to, now you can write this as 12 plus 1.3 bar. Is that clear?
Yes, ma'am.
All right, no problem till now. So this is basically 12 plus 1.3 bar, and that is nothing but 12 plus x, because this 1.3 bar was our x. So now when you take x to the left hand side, this becomes 10x minus x is equal to 12, which is basically what you would get if you did equation 2 minus equation 1. So here is what we have, 10x minus x is equal to 12. So now Hamna, what should I write next? Okay, Soya, can you tell me?
Yes, ma'am. Ma'am, 9x equals to 12. Then we can take 9 to the other side. Then x equals to 12 upon 9.
Yes, okay,
Yes, ma'am, we can divide.
right. So it is 12 by 9. Can we simplify this fraction further?
Yes, ma'am.
Yeah, what would that be?
4 upon 3.
4
Ma'am, 4
upon
upon 3.
So 1.3 bar, we said that it is rational because it can be written as 4 upon 3. So any doubts up until now?
Ma'am, we can do it also like, ma'am, by putting instead of a 12 plus 1 point bar 3 bar, by putting its original value 1.333.
Yeah, you mean you are saying that over here instead of 1.3 bar can we write 1.3333? Is that what you're saying?
No, ma'am, 12 plus 1, ma'am, 12 point, instead of 12 plus 1.3 bar.
I didn't quite get you. Instead of this, what else could we write?
Ma'am, 1.333.
Okay, you are saying instead of this, I can just remove this and write this. Are you saying that?
Yes, ma'am.
Achha. But just take a look at this equation, right? Take a look at, let me just take a look at this one. Okay, how did we get to this point? We got to this point. What was the first thing we did? We said, look, we want to operate on this 1.3 bar, or let me just rename it as 1.333, right? We want to take a look at this. So what we did, we said, okay, let's name it as x, and then we multiplied x by 10. So we multiplied that and we got 10x is equal to, so when we multiply, you have 1.333 and so on. So when you multiply this by 10, this decimal moves one place to the right. So we got 13.3333, right? Now, just a second. We got this. So that's how we got our second equation. Is it clear up until now, Midula? Is it clear till here?
Ma'am, yes, it's clear.
Yeah. So this is how we got this equation. Now what we did, we said, if you're suggesting that we remove this 12, it doesn't make sense. Why? Because on one hand, we are saying that 10x is equal to 13.3 bar. On the other hand, we are saying it is equal to 1.3 bar. Those are not the same, right? So just give me a second. Okay. Acha, acha. So I just read your message. You're saying first equation can be x point 1. Okay. Yeah, so we can, instead of this, or let me just erase this. Is this more comfortable to you guys?
Yes, ma'am.
Okay. So yeah. So this, you can also write it like this, no problem, because this and this are the same thing. This one and this one are the same thing. All right. So no problem. You can write it interchangeably. All right. So from here, from this equation, we said that okay, this is 13.3 bar. We can write it in the form of something plus x. That's what we've done here. That's the trick that we have to apply in such questions. So basically what we're doing is we are saying equation 2 minus equation 1. That's basically what we're doing. All right. So I'll just give you a quick homework question. How about you try out 1 point, let's say 27 bar. Okay. And the trick over here has to be, what you have to do is, instead of multiplying it with 10, you have to multiply it with 100. Why 100? Because you have two digits that are repeating, 27. So it will become, you have x is equal to 1.272727 and so on. So you multiply this with 100, you have 100x is equal to, now can you tell me, Zoya, what should I write on the right hand side?
Yes, ma'am. Ma'am, that 100x is equal to 100 into 1.27 into, then it will be 127.27 bar.
Yeah.
Yes, ma'am.
Right, so this 27 keeps on repeating. Now what you need to do is nothing but just subtract this from this, right? So you have to do 100x, like basically you take this, the green one, the green encircled equation, minus the blue encircled equation. So you just do 100x minus x, and then you will have 127.27 bar minus 1.27 bar. Then you will have 126. All right. So I hope you can do it from that, like afterwards. You can continue it from there.
Yes, ma'am.
Yes, ma'am.
So you have to do 1.27 bar, and I'll be sending some homework questions to you guys later on. So I hope you will be doing those. So any doubts in today's class? You can ask.
No, ma'am.
No, ma'am, no doubts.
All right. All right then. Thank you, class. See you all.
Okay, ma'am. Thank you.
Bye.
Thank you, ma'am.